So with that, our final speaker is Sandrine Elmi Hersi, head of the Open Internet Unit at Arcep, who will share with us thoughts from her experiences working on sustainability issues in digital technologies. She'll be joining remotely. So Sandrine, welcome.
Good morning. Thank you very much for the opportunity to speak at this W3C meeting after very interesting presentations highlighting a perspective in developing an ethical and accessible internet. So first, let me introduce a little bit myself and my work on sustainability. So as it was mentioned by Tara, I'm head of the Open Internet Unit at Arcep, which is in charge of eco-design topics. And Arcep is the French regulatory authority for electronic communications, postal and press distributions. Since 2019, we've been working on ICT sustainability with a wide range of stakeholders. And I was also co-chair of the Sustainability Working Group at BEREC for 3 years. And BEREC is a body that brings together a national electronic communications regulator across Europe. So today's presentation will include an introduction to key EU initiatives on ICT sustainability, as well as an overview of key figures regarding ICT's environmental impact, based particularly on one study published by Arcep. And finally, I will present to you briefly a practical tool to help integrate eco-design principles into digital and web services, the general policy framework for the eco-design of digital services. To begin, I'd like to highlight a shift of paradigm regarding the relationship between ICT and the environment. For a long time, digital technologies and internet were seen primarily as solutions to fight against climate change. But since the 2010s, thanks to the work of civil society, industry, and public authorities, there has been a growing awareness that what we used to consider as immaterial services actually depend on highly material infrastructures, meaning devices, networks, and data centers, all of which have a significant environmental impact. This shift in thinking is reflected in European policy and regulation, most notably in the European Green Deal launched in 2020 by the European Commission. For the first time, a major sustainability strategy included a full chapter on making ICT itself more sustainable, not just regarding how digital tools can enable sustainability in other sectors. Hence, this policy includes targets such as improved energy efficiency for digital infrastructures, circular economy principles in the ICT sector, as well as greater transparency regarding the environmental footprint of data centers and networks. Additionally, the European Commission's digital strategy includes an ambitious objective achieving climate neutrality for digital infrastructures by 2030. So these targets were translated into several policy and regulatory initiatives. So you can see on the map some of the most recent European Union initiatives related to ICT sustainability. You can see on your left that the European Union has progressively integrated ICT into its horizontal, broader sustainability regulation. For instance, the Empowering Consumer in the Green Transition initiative reinforces consumer protection, including against misleading claims about digital product durability and repairability. Another example is a recent regulation for sustainable products that created the digital product passport that was mentioned earlier by my UN colleague. The European Union also developed ICT-focused regulatory and policy instruments addressing their environmental impact. On that, a strong focus has been placed on hardware, particularly on devices that you can see on the right part of the slide. For instance, the European Commission published eco-design rules for smartphones and tablets in 2023 that is paired with the creation of a dedicated environmental label. Regarding data centers, the most recent development is the adoption of the recast of Energy Efficiency Directive, which introduces a mandatory environmental audit for these infrastructures. On telecom networks, at BEREC, we've been working closely with the European Commission on the development of a code of conduct for the sustainability of electronic communications networks and services. And of course, artificial intelligence is now a major focus of European Union action on ICT sustainability. We can, for instance, mention the AI Act, which permits the adoption of code of conducts addressing the environmental footprint of AI models, as well as an upcoming European Commission study on the energy consumption of these technologies. Within this context, in France, Arcep has decided to open a new chapter of its regulation focused on sustainability at the same time of the publication of the European Green Deal. Our goals are to firstly improve measurement and monitoring of the digital environmental footprint through studies, such as a study that I will detail just after, but also through data collection. And for your information, the World Bank and ITU published a joint study measuring the environmental impact of the ICT sector, which details Arcep data collection process and key results. We also integrate environmental concerns in our regulatory activities. And finally, we aim to support stakeholders in adopting higher environmental standards through practical tools, including by the publication of the General Policy Framework for the Eco-Design of Digital Services that I will also present today. I will now share some key figures of our study that we published along with the French Agency for the Ecological Transition, ADEME. It is a study focused on the environmental footprint of digital technologies in France in 2020 and with some projections in 2030 and 2050. Among the main findings, we outline in this study that ICT accounts for 2.5% of France's carbon footprint. This share is lower than the global average share of ICT sector greenhouse gases emissions, which is estimated to 4%. And this gap is related to the fact that France has a low carbon electricity mix due to nuclear and hydraulic power sources. Getting back to the study, this document also outlined that ICT causes other forms of environmental impacts, including resource depletion, metal, minerals, but also fossil fuels, e-waste generation, and high energy use. As shown in this slide, under a business as usual scenario, the sector's carbon footprint could almost triple by 2050, and also other environmental indicators are growing in this business as usual scenario. It is important to note that these projections are taking into account the impact of the rapid uptake of artificial intelligence that came a little bit after the finalization of the study. And as you know, large language models do require substantial quantity of computing power and contribute to a steep rise in data centers' energy consumption. For instance, the International Energy Agency has projected that global electricity demand from data centers could double between 2022 and 2026. In the face of this growing impact, what can be done? So we know that devices are currently the main driver of ICT's carbon impact, closely followed by data centers, especially at global level. But all components of this footprint are interconnected. Acting only on devices or data centers won't be enough because, for instance, to use a service, I have to use a device and also rely on the operation of material infrastructure, so data centers and networks. So Arcep and BEREC, we believe that we must act on the entire digital value chains, including networks, data centers, devices, and uses, and work holistically on digital services environmental footprint. One key lever to reduce ICT carbon and environmental footprint is through eco-design, meaning the integration of environmental considerations into product and service development. So far, as presented earlier, EU initiatives have mostly focused their efforts on material products. So to complement these actions, the French legislator tasked Arcep and Arcep, which is a media regulator in France, along with ADEME, so the French Agency for the Ecological Transition. So the French legislator tasked these authorities to develop a general policy framework for the eco-design of digital services. So we published this document in May 2024, and it also relied on work with multiple public and private stakeholders. The framework aims to provide a common base of best practices for ICT professionals to apply eco-design principles in digital services. So it includes 78 best practices and fact sheets, aiming to contribute to extending device lifespan by reducing software obsolescence. It also aims to reduce the negative impact of attention-grabbing features used by digital platforms. It also foresees the optimization of resource use across the life cycle of services and an increased level of transparency regarding the digital services environmental footprint. And it also enables the publication of an eco-design declaration and a progress score for a respective digital service. Here you can see some examples of the best practices included in this general policy framework for the eco-design of digital services. Just to mention two of them, one of the most important best practices is to ensure that digital services are compatible with devices that are old, and we aim devices of 7 to 10 years old, depending on the service. This helps to fight against software obsolescence. A second example would be the important focus of this framework on video optimization, including through the promotion of efficient video compression codecs and avoiding autoplay and similar attention-grabbing techniques. This framework also includes an entire section on the eco-design of artificial intelligence, which I won't detail today, but it's a major pillar of the document. So to conclude, the ICT sector must reduce its own environmental footprint if it is to support the green transition across all sectors. Besides, in a context of resource scarcity, including metal, mineral, and fossil fuel, optimizing digital resource use is essential to preserve access to connectivity for future generations. However, today, ICT is one of the fastest growing sectors in terms of environmental impact. So we need to keep improving how we measure this impact, especially integrating emerging technologies in the mix, because better data enables better action, and international standards have an important role to play in this context. Besides, a holistic approach is necessary, addressing devices, networks, data centers, and digital services together. And eco-design is part of the solution and should be applied to services as well as hardware. And we have now actionable tools to work on this objective. So the policy framework that I presented, but also the W3C sustainability guidelines. And finally, while national and inter-regional initiatives are a crucial first step, only a global multi-stakeholder approach will allow us to reverse the current trajectory of ICT's environmental impact. Hence, W3C platform will be one of the key factors in achieving successfully digital sustainability. So thank you very much for your attention. The very final slide display some links to the documents I presented. So the ADEM Arcep study and the framework regarding the eco-design of digital services. Thank you very much.